Hi everybody, it's Miss Billingsley. Today we are going to be taking some notes over writing linear equations from a graph. Now this is something that some of you already know how to do. I've seen it in some of our practices, but we're going to do a little bit of review and a little bit of new stuff. Okay, so the first thing we're going to do is slope-intercept form. This is our most favorite form to write equations in because it is the simplest. There's only two things that we need. And as a reminder, that slope-intercept form looks like y equals mx plus b. Okay, go ahead and write this down with me. And let's get a smaller pen. Okay, we want to write an equation in this form from a graph if we know a y-intercept. Okay, if we have a y-intercept that can be easily determined, that means there's no fractions, no guesswork behind it. Like on this graph right here, I'm looking across my y-axis. Okay, and I notice right here it crosses at a nice, good spot. So I'm going to go ahead and put a dot there, and that is at -1 on my y-axis. Okay, so right away I already know that my b, remember b is the y-intercept, and m is our slope. I already know that my b in this case is at 0, -1, or is -1, my y-intercept. Okay. And now all I need to do is find the slope, the rise and the run. Remember that we put the rise on top, and then we divide by the run. So we always want to choose two good points to look between, and on here they're labeled for us A and B. That would be a good place to look. We could even look between A and this point. So it doesn't really matter. If it's simplifiable, then we will simplify it. So we're just going to pick two good points to look between. Any of these will do. Okay, so right here my rise is down 2. I'm going to actually go to this point. I lied. Okay, right here I'm rising actually in a negative direction, so I'm actually going to have a negative rise there, and my run is 1. I'm just going 1 unit to the right between those 2 points. So I'm going from A to this point, down 2 over 1 for my slope, and this simplifies just to -2. If we divide -2 by 1, we get -2. Okay, so all I now need to do is to plug these numbers into m and b, and then I'll have my equation in slope-intercept form. So I have y equal to, we said our slope was -2, so now I have a -2x. And then I'm adding my b on, and remember we said b was a -1, so we'll actually subtract it there. You could put plus a negative, but the negative overpowers the plus, so this is our final answer here. Y equals -2x minus 1. Okay, so that is how we write an equation from a graph in slope-intercept form. We need two things, slope and intercept. If they're both easily determined, both visible whole numbers, then we would want to use this form. Okay, I'm also going to use this opportunity to show you how to convert your equation into standard form. We haven't seen that yet. We've seen converting into slope-intercept form from point-slope form, but we can actually really easily take this equation that we just came up with, our y equals -2x minus 1, and convert it to standard form. Does anybody remember what standard form looks like? Awesome. If you said ax plus by equal to c, then you are correct. And remember, the only thing that we can really hold on to here, the only facts that we know about this is that c is some total in a word problem. But we also need to note that a, b, and c must be integers. Does anybody remember what it means to be an integer? Okay, that means there must be no decimals or fractions. They've all got to be whole numbers. A, b, and c need to be a whole number, an integer. Okay, so the way that we convert this equation in slope-intercept form into standard form is to get the constant number, okay, the one without the variable, by itself. So right here, I'm identifying my constant here as c, or sorry, -1 as c, And I need to move this 2x over here. Okay, I need my variables together on one side and my constant by itself on the other side. So all we have to do here is add the 2x to the other side. Remember, I'm undoing it here so that those cancel and go away. And over here, I'm left with 2x plus y, that's a positive y there, equal to -1. We really like for the x to be first and the y to be second. But that's all there is to it. We just need to get the variables together. So a little rearranging and we are in the form that we need, okay? So right here, I'm just gonna write what my a, b, and c are. Right here, my a is the 2. The b, the number in front of the y, I know there's not one, but what is it if there's not one visible? There's still a number there, and it's a 1, very good. So b is 1, and then my c value is -1, okay? All right, so we just did a little conversion into standard form. Last thing we're gonna look at is point slope form. Let me scroll. Okay, so point slope form is the y minus y1 equal to m times x minus x1. And we want to choose this if the graph includes a y-intercept that cannot be easily determined, like right here. That's a fraction of some sort. It doesn't even look like it's 1/2, so I can't make any assumptions. I need to choose point slope form. Okay, so as we know already, point slope form requires a point and a slope. I can choose any point from the graph to plug in for x1 and y1, okay? So what we're gonna do here first is find our slope, our m value, the rise over the run, okay? Okay, let's choose 2 good points, and because a and b are labeled, why don't we choose those? Let's take our rise over our run. You tell me what it is. Very good. This one is also negative. It actually is rising in the negative direction. So my rise is -1 and my run is 5. Okay, and that actually doesn't simplify. So our slope is going to be -1/5. Remember, when we're looking at graphs especially, we want to leave our slope as a fraction. So -1/5 there for our m. And we can actually choose either point A or B. If there was other good points on here, we could choose those too, but notice that all the other ones cross at non-integers. So let's choose A or B, and I will show you both ways. If we choose point A, our equation is going to look like this. Our point A is located at -3, -2. Okay. Our point B is located at 2, -3. So we can use either one of these points. We don't have to do both. I'm just going to show you both so you know both ways. Okay, so my formula says y minus y1, y minus, and my y1 value is going to be this -2. Do we remember what happens when I put 2 negatives in? Yeah, that actually becomes a positive right there. So we're going to have y plus 2 equal to my slope, which was -1/5, times x minus my x1 value, which again is a negative, so that's going to turn to a +3 this time. Okay, so that is one possible answer. If you said that, that is correct. That would be one completely valid option for the point slope form from a graph. If we choose point B, it's going to look pretty similar. We're going to start again with that y minus y1. My y1 here is a -3, so that actually turns to a +3 there, equal to my slope, which is -1/5, times x minus x1. Notice here, that's a +2 this time, so it's going to appear to be negative when we plug it in. But we're plugging in a +2 just due to our formula having the negatives. This one looks like it's negative. Okay, so that is also another valid option for the answer. Either one of those work. We want to choose this if we don't know the y-intercept. Obviously, if we do, then we would choose that form. Okay? All right, that's all I got for you today. If you have any questions, please let me know by email, and I will talk to you soon.